Okay, welcome to the Density of Solid Labs. Today we're going to do the measurements. Well, I'm going to be your hands and your eyes. You're going to make the measurements. So what we really want to do is fill out these quantities here. We need to measure the lengths, widths, and heights of the aluminum slab and the aluminum cube, and we need to measure the diameters of the steel ball and the glass ball, and we need to measure the masses of all four objects. So let's start with the dimensions of the aluminum pieces. I reposition. Try and get up close. This is the aluminum slab. It's got 3 dimensions. So starting at 0 and lining it up so that you can see right down it. This is a centimeter scale. You should write down the length of the aluminum slab. Okay. As far as the width goes, if I line this up, 0 on one edge, and I reposition in front of the camera so you're looking right down that edge, you're going to record the width in centimeters. To measure the height, I'm going to tip it on edge. I'm going to line up the ruler, and then I'm going to reposition our viewing angle. So we're looking on that. You should write down the width in centimeters. Okay, that's the slab. This is the aluminum cube. I'm going to look down the edge and line up the ruler with one edge, and I'm going to reposition our sight line, and you should write down about there, and you should write down the width. This is an actual cube. All the dimensions are the same, so you should fill out the height and the length to be the same value. All right, to measure the steel ball diameter, I'm going to use this tool. It's called a caliper, and it's got a little moving scale. If you look at the little 0 right here, when I get to 1 centimeter, that's exactly 1 centimeter. So I'm going to put the ball in here because it would be difficult to measure something, and I'm going to zoom in on this. So you can see we're past 1, we're below 1.5, and you should write down the dimension in centimeters on the bottom on the scale right here. Okay? That's the diameter of the steel ball. For the glass ball, I start out with 0, and I have to open it up to 1, and I have to open it up a little bit more, and I get that in the jaws, and you look at that. Oop, fell out. Hold this in front of the camera, and you should write down that dimension as the dimension of this glass ball. Okay. That's all the dimensions. Raw data. Now for the masses. We have a balance here. Okay. So we check that it's zeroed. It's measuring in grams. We put the slab on. and you get 54.1. I don't know if we can see. I'm going to reposition this so that we can see down and see the decimal points. Okay, that's the mass of the aluminum slab. And we take our cube, check that it's still 0, and put the cube on. And we get a mass in grams for the cube. To measure the balls, they would roll around and it would be difficult. So we're going to put this container on there, but we have to 0 it. Wait to make sure it's 0. And we've got the steel ball, and we put it in, and we get a mass for the steel ball. Then we take out that. We make sure it has re-zeroed. It has. We put the glass ball on, and we get a mass of the glass ball. Okay, so that is all of the measurements that we need to make to fill out this data table. We're going to be filling it out. We should have the length, width, and the height of the aluminum slab and the aluminum cube, and we should have the 2 diameters of the steel and glass ball, and we should have all 4 of the masses of the objects. That's all the raw data we need.